here's our timeline for this week. Lots of points up for grabs, so I just want to make sure we're all on the same page. Tomorrow is your homework check. Don't forget that Chapter 6 is in on this homework check. So make sure you bring your notebook or wherever you did your Chapter 6 homework. I've been having not really a problem with the homework check, but I feel like some people aren't quite getting the concept of it. So as far as like homework checks and quizzes and tests, once you have it in your possession, you are finishing it. So there's no like, I'm going to start my homework check and then I got to go to the nurse or something. Then it's graded as is. Once you touch it, you finish it, okay? No matter what happens, you're finishing it that time, okay? I've had some issues with people starting it, and then they have to go somewhere, and then they come back, and by then it's not really a homework check because you know exactly what problems are on there, and it kind of ruins the point. So from now on, if you start a test, you're finishing the test that day. If you start a homework check, you're finishing the homework check that day. I'm also making a couple versions of the homework check, just so there is no temptation to tell anyone what questions are on there. It just kind of prevents us from any problems moving forward, especially since it's winter and lots of people are absent often. Okay? So that's tomorrow. I am going to have your reviews printed by tomorrow as well, so you guys can start on those once you finish your homework check. Wednesday is all-day review, and then your test will be on Thursday in this class. Friday we're going to the computer lab to do a practice park test. I do want you guys to take it seriously, so I am going to have some way to assess points. It might just be you were there and I saw you working, so you get points. I might make you write a little something. I haven't decided yet, but there will be points every day this week except Wednesday. So I would definitely try to be at school, try to be present, not just physically but mentally as well, and let me know if you have questions when they arise. Yes?
How much is our test worth?
Your test is worth 100 points. Your homework check is worth 50 points. Thank you. The computer lab thing is probably worth 10 or 20 points. I haven't decided. Usually I do projects worth 20, so it's kind of like a project. All right. Any questions about this week's schedule? All right. This is the last section. It's actually... You okay? I would love for you all to get 100 on your test. That would be great. Oh, no. I don't want anyone to fail anything. Okay, good. All right. We do need to get going today. So this is section 7.6. It's all about solving radical equations. So we graphed with radicals, but now we're going to solve some equations with radicals as well. Eric, I know you were super excited about last night, but we need to rope it back a bit.
Sorry.
It's cool, but you're on the internet, so it's cool. All right. We are going to start by solving equations with radicals. As the day progresses, they will get a little more challenging. This is a fairly simple one. All right. What do you guys think we should do first?
-2.
Yes, subtract 2 from both sides. Now, how would you undo taking the cubed root of something? Cube it. We've kind of gone in reverse, right? We've had something cubed and we take the cubed root. Works the same way. They undo each other. So if you want to undo a cubed root, you cube both sides. That leaves you x equals -8. Here's number 2. What do you guys think we should do? Add 5. Good. Then what? divide by -1. Before we can do anything with squaring, we want to get the radical all by itself. So we divide everything by -1, then we square it. So x equals 1. If you plug 1 back in, the square root of 1 is 1. -1 minus 5 is -6, so this works. What would I do here? To the 4th. Good. Gives you 81. Now, when you take the 4th root of both sides, you know you have to do the plus or minus. You don't have to do the plus or minus here, okay? Whenever you take the 4th, that takes care of the plus or minus, because if we had 3 to the 4th, it'd be 81, or -3 to the 4th is still 81, okay? So you don't have to add the plus or minus on this one, but if you're doing this problem in reverse, if you have something to the 4th and you take the 4th root, then you do it. Questions? Almost. Divide by just 2. We'll deal with the exponent in a second. So divide everything by 2. We get x to the 1/2 equals 9. Now there's 2 ways to approach this problem. You can think of what would make this exponent a 1. X to the 1st is the same as x. So if we can turn this into a 1, and our exponent will be good. Or you could change it to square root and then figure out how to solve it from there. What would you multiply a 1/2 by to turn it into a 1, though? A 1/2 times a 1/2 is a 4th. 2, right? So if I multiply this by 2, I would just have an x and an 81. Or, from that step, if you don't like rational exponents, change it to the square root of x equals 9, and then you can very easily see that squaring both sides will work for you. Either way is fine. Any questions? Divide by 5. Good. So x to the 3/2 equals 8. Now, I kind of told you on the last one, just think of what you need to multiply this by to make a 1. It's always the reciprocal. So what's the reciprocal of this? 2/3. So if you take both sides to the 2/3, that'd be x to the 6/6, which is x to the 1st. And then you can do 8 to the 2/3 in your calculator. Or you could square it and take the cubed root. Either way, you should come up with an answer. Anybody have it? 4, good. So whether you want to change it to a cubed root, do the cubed root of 8 and then square it, or you can square the 8, then do the cubed root, or you can do it in your calculator like this. Multiple ways to get at that same answer of 4. Any questions? What do I want to do to both sides? Yes?
4/3.
Exactly. Take it to the 4/3. Now, you can do 1 to the 4/3, which would give you a 1, and then 8 to the 4/3, or you could do 1/8 to the 4/3 and just make sure you give me your answer as a fraction. 1/16. Good. 1 over 16. Check on your calculator to see if you can get it. If not, I can show you how to write it out with radicals if you'd rather see it that way. I can show you that either way. So you're basically doing the third root of 1 to the 4th of 8 to the 4th. Okay. Should all give you the same thing, 1 over 18. Questions? So these aren't so bad once you get the hang of them.
How many examples?
Lots. I want to say like 16 examples. They're going pretty quickly though. We're already on 7. All right, now we're just looking at what do you do when there's a few terms under the square root. What do you think?
Doesn't it go to the left 3 times? I remember that. 3 units.
Talking about shifting transformations.
Oh, yeah, if we were going to graph this. Okay, we're not graphing it, though.
Just square both sides.
Yeah, you can square that whole left side, and then you're just left with 4 plus 3x equals 100. No, you were on the right track. If I would have said graph it, yeah.
Minus 4.
We ever gonna graph these?
Oh, we did on Friday.
Oh yeah, we did.
And then you divide by 3. And of course, we're getting 32. If you plug it in, you get 96 plus 4, and then you take the square root. Square root of 100 is 10, so this one checks out. Questions? Same type here. How would we start? Square both sides. Good. So you're left with 2x plus 1 equals 49. And then it's pretty easy from there. That's just a 2-step equation. You guys have been doing those for years. You should be getting a 24. Questions?
Cube.
Yep, same type here, except you're not squaring both sides, you're cubing both sides. So you're just left what was under your radical, 4x minus 1, and then now it equals 27 instead of 9. Be careful about this. Some of you were not so good at working the other way on that quiz. Like if it was an x to the third, you take the square root. That doesn't work. You got to take the third root or the cubed root. Okay, so be careful on that. All right, I got to add that 1. I got to divide by 4. We get 7. If you plug 7 in, you'll get 28 minus 1, which is 27, and the cubed root of 27 is 3. Questions? Pretty easy way to end the chapter, right? Okay, good. We'll keep going though. Tell me to slow down if you get confused. What do you guys think? Square both sides. That's magical. 7x minus 8 equals 5x. Now, notice that everything was under radicals. So we didn't actually square anything. We just canceled out all those radicals. We undid all the radicals. All right, now what?
Subtract 7.
Subtract 7. You want to get all your x's together. And then divide by -2. These are ones that I would especially make sure that you're checking your work on because these get kind of tricky. If I plug it in on the right, I'd get 20, square root of 20. On the left, I would get the square root of 20. So this one does check out. You don't actually have to know what the square root of 20 is, as long as you know that it's the same thing on both sides. Questions? And I need to square both sides. Good. Am I actually squaring anything, like 3 times 3? No. Some people make that like 9x plus 25. You can't square things more than once unless you do that to both sides, okay? So if you're just squaring it, all you're doing is getting rid of the radicals on both sides. If something was outside the radical, then you'd square that. But anything inside the radical, you're not actually changing the numeric value. You're just getting it out from underneath the radical. Simple, get your x's together. We get 2x equals 10, and then x is going to equal 5. Again, this is one that I would make sure it actually works. If you plug it in on the left, you get 20, square root of 20, and on the right, you get square root of 20. So same as last time.
I have a question.
All right, here's number 12. Now, as you're thinking of what to do, pay close attention to this guy. He's like all alone in the world. Poor little 2. What do I need to do to both sides? Now look, if you divided it by 2, then you just have a 1/2 over here. Does that help, really? No. So, I mean, you can move the 2 back and forth to either side, but either way, you're not really going to get your x's together, and you're not really going to get the 2 away from the x's because there's x's on both sides. So what else could we do? Yeah, you're going to still cube everything. On the left, all you did was undo that cubed root. So you just had the x plus 14. What do you think this 2 is going to do? Yeah, it's going to become an 8. And then when you take the cubed root of x cubed, you just get x. So check this side out. Let me know if it's confusing to you. But since the 2 is not under a radical, we just took it to the 3rd power. And then the 3rd power canceled out the cubed root part. So we just had the x. Kind of tricky. Not too horrible, though, once you give it some thought. Subtract the x now. And then divide by the 7. This is one I would still check out. If you put a 2 under the radical on the left for the x, you get 16. You could pull an 8 out because I know that the cubed root of 8 is 2, so I get 2 square root of 2. And then over here you get 2 square root of 2, or 2 cubed root of 2 as well. Sorry, so this does check out. This is a little harder to check, but it still works. Questions? Or honestly, if you're just checking to see if a solution works, you can see if you get the same decimal in your calculator. That's fine. Any way you want to check it works for me. Or don't check it at all. Live on the edge. Questions? All right. Only 12, I guess. Sorry, I overestimated our number of examples. Here is your homework. Again, it's an EOO, every other odd. So you're going to do 17, skip 19, 21, skip 23, 25, skip 27. You guys get it, okay? Homework check is tomorrow, so you have about a half an hour. I would use that whole time. Come to tutoring if you need to. Let me know what questions you guys have, but when I see you tomorrow, the homework check begins.